Yes, friends, there is one question in this video, very important. Numerically, this is a proton, a neutron, and an atom particle enter the magnetic field at right angle to B. B means magnetic field with same kind energy. Compare the radii of their circular path. Compare the radii of their circular path. So first of all, we should know what is proton, what is neutron, what is other particle. Proton is very common. I am writing here name of particle, name, charge, and mass. Proton has charge plus E, or suppose mass is M. Neutron. What is neutron? Neutron is the nucleus. Neutron is the nucleus of deuterium. Hydrogen has three isotopes, one H1, one H2, one H3. This is called protium, deuterium, tritium. Atom है atom. Nucleus of deuterium. Nucleus deuterium called neutron. What is this has? It has one proton, one neutron. Nucleus. So its charge is plus E, mass 2m, mass of proton. Alpha particle has charge, it is helium nucleus. Alpha particle, it is 2He4, nucleus of helium. So it has 2e charge or mass 4m. First of all, we must know this thing. Question you have noted that proton, neutron, or deuteron and alpha particle, all are charged particles. Enter magnetic field B normally with same kind of energy. To find the ratio of the radii. You know radius followed by charged particle mv upon qb. Here we are given that they have same kind of energy. So how to relate kind energy? You know very well that kind energy of particle equal to half mv square. If I write it as k equal to mv, or I can write k equal to half mv square. If I multiply and divide it by m square v square upon 2m. So, m. So m square v square equal to 2mk, and hence mv equal to under root 2mk. This is very important relation, dear student. Actually, generally we write p square upon 2m equal to kind energy k, or p equal to under root 2mk. So here mv come to mk, so radius can be as under root 2mk upon qb. Q is the charge. So radius of proton rp under root 2m mass k, kind energy k, and charge eb. R for deuteron D. I write deuteron for D. Capital D. It is under root. Its mass is 2m. K charge तो E है. For radius for alpha particle. Under root 2 into 4m. कोई mass of alpha particle 4 times the mass of proton. K upon its charge is 2e. Charge of her particle 2e. I will make the table. Or it can be written as because 2, 4 root 2, this 2 cancel. I mean, you get it as under root 2mk upon EB. And therefore, if I write here Rp upon Rd, you will get 1 upon root 2. 2m cancel, EB cancel, so root 2 is there. Rd upon R alpha, it is root 2 by 1, and hence Rp ratio Rd ratio R alpha is equal to, ऐसे लिखते हैं या इक्वल टू लिखो कोई दिक्कत नहीं है, 1 ratio root 2 ratio 1. So this is a very simple question here, and generally in competitive exam and board exam this question is asked. Now you may be given same velocity, a proton, you may be given only 2 particles like proton and neutron having same kind of energy. If I say proton and neutron, proton and neutron enter the magnetic field with same kind of energy velocity. तो सिंपली भाई मास इसका m चार्ज e, इसका मास 2m e, तो रेडियस ऑफ प्रोटॉन क्या होगा mv अपॉन eb, और इसका क्या होगा न्यूट्रॉन के लिए 2mv अपॉन eb, यानी कि rd जो है ट्वाइस ऑफ rp होगा, ऐसे पूछ लेते हैं. So be very careful while you are attempting question in board. Deuteron. I think I have written spelling of deuteron wrong, du. Deuteron is like this, deuteron. Please correct it. Actually, due to this high temperature in the room, nowadays it's very hot here. Rainy season has lot of humidity in my place. I can't run AC because it creates sound. One thing more, dear student, when charged particle enter magnetic field at any angle, एक ध्यान नोट कर लो, ये बात बड़ी इंपॉर्टेंट है. Actually, 1 year I gave this question in half yearly exam in our school. So nobody could understand the question and start crying the question is wrong. Question ये है कि if a charged particle enters a magnetic field, then it experiences a force which is due to magnetic field. So how much work is done? How much work will be done by this force? Though I have told it in last video, when charged particle enter magnetic field, it actions force due to magnetic field. You know क्या कितना होता है फोर्स को, वेक्टर है इक्वल टू q into v क्रॉस v. So they were asking the students appearing the exam, asked me, sir, something is left in this question. You have not given the angle at which the particle enters the field. Whatsoever the angle, if charged particle enter magnetic field, then force is determined by this. Maybe 0, maybe any. So they were thinking that it should be given the particle and field parallel to the magnetic field. Because when enter particle parallel, it actually no force brought done. So here, I think you have got the answer or not. The charge particle enter magnetic field. Force is V cross B, F into V cross B. Direction of F perpendicular to velocity V. And I told you that work done. F dot D, dot product of force and displacement. Direct displacement is along velocity. So this force is at right angle displacement and no work is done. Please note it. When charge particle move in magnetic field, whatsoever is the angle, if the particle enter magnetic field parallel or anti-parallel, तो force zero, क्योंकि magnetic field force क्या है? QVB sin theta. If theta is 0 degree or 180, sin 0, 0, sin 180, 0. तो the force है ही नहीं. तो they were expecting कि अब मैं थीटा बताऊं उनको कि वो 0 है. I mean, so my question is there. Generally, this is asked how much work is done. I have told you in last video, force acting at right angle does not do any work. But I am reading again this question here. So please note it. When charge particle enter magnetic field, the force acting on it due to magnetic field does not do any work. You can note W is equal to 0. Work done 0 when charge particle enter magnetic field. Why? Because force is at right angle to B and B both. Force acting at right angle does not do any work. So this was all about the force of magnetic field, work done, and circular path or helical path, etc. I will take next video and will tell you torque on current carrying loop in magnetic field.